How to calculate molar mass? Calculation of molar mass of carbon dioxide. We need to know first how to count the number of atoms. So I am referring to this video where it explains how to count the number of atoms. So first is we have to identify the type of atoms and the number of atom. So in the formula, we have one subscript of carbon. That is why we have one carbon atom. Two subscript of oxygen. That is why we have two oxygen atoms. And from the periodic table, the atomic mass of carbon can be taken. Carbon is 12.01 and oxygen is 16.00. So we get the masses of carbon and oxygen atoms by multiplying the number of atoms by the atomic mass of carbon, multiply the number of oxygen by the atomic mass of oxygen, and then get the total. And we have 44 grams of carbon dioxide, and the unit is per 1 mole of carbon dioxide. So 44 grams of carbon dioxide over 1 mole of carbon dioxide. So what is the meaning of that? It means that 1 mole of carbon dioxide molecules weighs 44 grams, and it can be written as either 44 grams of carbon dioxide over 1 mole of carbon dioxide, or 1 mole of carbon dioxide per 44 grams of carbon dioxide. Another model is calculation of molar mass of sugar, C12H22O11. Again, the first step is list down the type of atoms and the number of atoms. So we have 12 carbon, subscript of carbon is 12, so it means we have 12 carbon atoms. The subscript of hydrogen is 22, therefore we have 22 hydrogen atoms. The subscript of oxygen is 11, so that means there are 11 oxygen atoms. And from the periodic table again, the atomic masses of carbon and hydrogen and oxygen can be found. And for carbon is 12.01, hydrogen is 1.00, oxygen is 16.00. So let us get the mass of each atom. So we have each type of atom. So we have to multiply the number of carbon atoms, which is 12, by the atomic mass of carbon, which is 12.01. 22 is the number of hydrogen atoms multiplied by the atomic mass of hydrogen atoms. And to get the mass of oxygen, we have to multiply the number of oxygen by the atomic mass of oxygen. So getting the sum of all the masses of these atoms, there are 342 grams of sugar per 1 mole of sugar. It means that 1 mole of sugar molecules weighs 342 grams of sugar, and it can be written as either 342 grams of C12H22O11 over 1 mole of C12H22O11, or 1 mole of C12H22O11 per 342 grams of C12H22O11. Okay, the next model is calculate the molar mass of aluminum hydroxide. Again, the first step is to list the number of atoms in the formula and the type of atom. So, the subscript of aluminum here is 1. That is why we have 1 aluminum atom. Okay, as you can see in the formula, outside the parentheses, we have subscript 3. So we need to multiply this 3 by the subscript inside the parentheses. So 3 times 1 of oxygen is 3 oxygen atoms, and for hydrogen, 3 times 1 oxygen is 3 hydrogen atoms. Again, from the periodic table, the atomic mass of aluminum is 27, oxygen is 16.00, and hydrogen is 1.00. So, get the mass of aluminum by multiplying the number of aluminum atom by the atomic mass of aluminum. Get the mass of oxygen by multiply the number of oxygen by the atomic mass of oxygen. The mass of hydrogen is taken by multiplying the number of hydrogen atoms by the atomic mass of hydrogen atom. So getting the sum of all the masses, it is equal to 78 grams aluminum hydroxide over 1 mole of aluminum hydroxide. It means that 1 mole of aluminum hydroxide weighs 78 grams, and it can be written either as 78 grams of aluminum hydroxide per 1 mole of aluminum hydroxide, or 1 mole of aluminum hydroxide per 78 grams of aluminum hydroxide. Okay, so another practice is molar mass of ammonium sulfate. As you can see again, we have to list down the number and the type of atoms in the compound. So here you have the outside the parenthesis, the subscript is 2, meaning you have to multiply each inside the parenthesis by 2. So nitrogen is 2 times 1 subscript, that is why you have 2 nitrogen atoms. The subscript of hydrogen is 4 times 2. That is why you have 8 hydrogen atoms. And in the formula, you only have 1 subscript for sulfur. That is why you have 1 sulfur atom and 4 subscript for oxygen. That is why there are 4 oxygen atoms. And again, from the periodic table, the atomic mass of nitrogen is 14, hydrogen is 1.00, sulfur is 32.06, again, oxygen is 16.00. So let us get the mass of nitrogen atoms by multiplying the number of nitrogen atoms by the atomic mass of nitrogen. The, the number of hydrogen atom multiplied by the atomic mass of hydrogen atoms to get the mass. To get the mass of sulfur, multiply the number of sulfur by the atomic mass of sulfur. And to get the mass of oxygen, multiply the number of oxygen atoms by the atomic mass of oxygen atoms. So, getting the sum of all the masses of these atoms, it is equal to 132.06 ammonium sulfate. And the unit is 132.06 ammonium sulfate per 1 mole of ammonium sulfate. It means that 1 mole of ammonium sulfate weighs 132.06 grams, and it can be written as 132.06 grams ammonium sulfate per 1 mole, or 1 mole of ammonium sulfate per 132.06 grams ammonium sulfate. And the last model we have is this, molar mass of copper sulfate pentahydrate. Okay? So again, the first step is to identify the type of atom and to count the number of atoms. Copper here, you only have 1 subscript, therefore 1 copper atom. 1 sulfur atom. You have 4 subscript for oxygen, so 4 oxygen atoms. And hydrogen, you have 5 coefficient of H2O, so you have to multiply everything by 5. So 5 times 2 10 hydrogen, and 5 times 1 oxygen is 5 oxygen. Okay, so again, the atomic mass can be found in the periodic table. Copper is 63.55, sulfur 32.06, oxygen is 16.0, and hydrogen is 1.00. So let us get the mass of copper by multiplying the number of copper atom by the atomic mass of copper. For sulfur, the number of sulfur atom is 1 multiplied by the atomic mass of sulfur. And the mass of oxygen is multiplied that at number of oxygen 4 by the atomic mass of oxygen. And for hydrogen, number of hydrogen by the atomic mass of hydrogen. And another oxygen here is 5 oxygen times the atomic mass of oxygen. So, getting the sum of all these masses is equal to 220.15 grams copper sulfate pentahydrate over 1 mole of copper sulfate pentahydrate. So that means 1 mole of copper sulfate pentahydrate weighs 220.15 grams of copper sulfate pentahydrate and can be written as either 220.15 grams of copper sulfate pentahydrate per 1 mole of copper sulfate pentahydrate or 1 mole of copper sulfate pentahydrate per 220.15 grams copper sulfate pentahydrate.